Punta na tayo sa limits and infinities. Okay? As I mentioned, you can use also limits to observe infinity behaviors. Okay. Okay. Kaya natin to. Okay. I will just show you the definitions, but then again, we'll be more focused on the computational aspects for this one. Okay. Here are the two general ideas of limits involving infinity. The first two are called as infinite limits because as limits, you have the infinities. But then let me tell you, when you say infinite limits, in fact, these are limits that do not exist. When you say limit, that is actually a real number. When you say infinite limits, you are not really saying that the limit is infinity. What you are saying is in fact behavior. So ibig sabihin po niyan ay, bakit ayaw naman ng pen kong gumana? Sorry. Ang ibig sabihin po ito ay behavior lamang. Sorry sa penmanship. Clear na nga natin muna lahat yan. I'm having problem with my pen. Di ko alam kung bakit. Ay, sorry. Close caption. Erase all ink. Okay. So ito po ay behavior. Okay? So when you say infinite limits, positive infinity, negative infinity, hindi pa rin po nag-i-exist ang limit na yan. These are two examples of limits that do not exist, but then we can observe behavior. We mean that as x approaches a, the values or the function values increases specifically without bound. Ito namang isa, the function values decreases without bound going to the negatives. So again, infinite limits are not limits per se. What they give us are behaviors. So when you say infinite, negative, infinity, ang nakuha yung limit, the limit still does not exist or do not exist. But instead, you can get some behavior. Okay? Ito namang isa is limits at infinity. But then do be very careful at the term. The term that they use is limits at infinity when in fact, hindi ka naman pwedeng pumunta sa infinity because again, infinity is not a fixed point. Of infinity is just a behavior. But then this is the term that they are using. So at this point, I'm just clearing the term. Baka kasi sabihin nyo limits at infinity. So ibig sabihin nakakapunta ka sa infinity? No, it does not mean that. It means that we can observe behavior as x increases without bound or as x decreases without bound. Okay? So when you talk of infinities, they are in fact just behaviors, not specific values, not specific points on the axis. They are simply behavior. So in fact, for limits at infinity, we are asking, what is the behavior of the function as x increases without bound or as x decreases without bound? Okay? They are called limits at infinity, infinite limits, but then the proper way of reading them, nasan yun? Mamaya paling proper way of reading them is reading them as without bound. For positive infinity, increasing without bound. For negative infinity, decreasing without bound. Ibig sabihin, it will just continuously increase for positive infinity, or for negative infinity, they will just continuously decrease. Because again, infinities are not fixed values. Infinities are just behaviors. Okay? So tingnan natin, kailan ba tayo nagkakaroon ng infinity behavior? I'm pretty sure you already encountered such functions. Let's say this one. Hindi ko na kayo i-ask mag-substitution dito, but then this is the function. The domain is the set of real number except negative 2. This is one example of a classic rational function. And I think some of you are already familiar with this. When you talk of rational function, ito yung mga function na pag ginarap ay merong mga, ano tawag doon? Rational functions. Ano yung classic property niya? When you graph this type of functions, ano yung thank you, Mark, again. It's called as asymptotes. Some of you are again familiar with that already. So ito yung mga asymptotic behavior. Let's see. Ano may ibig sabihin ng asymptotic behavior? Ito muna from the left of negative 2. From the left of negative 2, notice, ito yung mga values, negative 3 up to negative 2, 0, 0, 1, and you can go further. And ito namang isa from the right, starting from negative 1, negative 1.5, and then going nearer and nearer to negative 2 from the right. But then let's see. I will not ask you to compute for this one. These are the values that you are going to get. Okay? Look at the values from the left. 10, 17, 31, 73, and bilang in by this one, 700,000. And also from the other one, 699,000. In fact, that will continuously increase as you go for 2.0000001 or 1.9999999 and so on and so forth. For this type of function, we are going to have those infinity behaviors, meaning the function values are increasing without bound or decreasing without bound for the case from the right. Again, from the left, the functions are increasing without bound. From the right, the functions are decreasing without bound because these are in the negatives. Okay? And in fact, ito yung ina-expect nating graph dito. Ito po yung x equal to -2. There will be a vertical asymptote. From the left, it will just be increasing. And then from the right, it will just be decreasing. But then of course, hindi pa natin ito na-justify ha. Somehow, probably your pre-calculus or algebra class taught you that if you are given a rational function, automatically there will be a vertical asymptote, in this case x equal to -2, and immediately you're going to get this type of graphs, this asymptotic behavior. But then the question is, what will justify that asymptotic behavior? And that is one role of a limit. A limit will actually tell us that there will be an asymptotic behavior from the left and then from the right. I forgot if it is in the next slide already. Ayan. So yeah, it's in the next slide. So the limit behavior will tell us that from the left, it will really increase without bound. But then from the right of -2, it will decrease without bound. Okay, the rules I will show you in a short while. Let me just first complete this part. Now, from the left of -2, we can see that the function values increases without bound. And if the function values increases without bound from the left of -2, that is, increases ano? That is the part that we say that the limit will be this positive infinity. Again, this is not a fixed value. This simply indicates the function values from the right increases without bound. As compared to this other one, let's just go back. Okay, from the left, there will be an asymptotic behavior, but then this time going to -infinity. So that's why going to -infinity from the right of -2, that is the part that we say that the function values decreases without bound. And by notation, we're going to write it as this one. Okay. We are not saying again that the limit is positive infinity or that the limit is negative infinity. Again, we are not saying that. For simplicity, pwede nyo sabihin the limit is positive infinity, the limit is negative infinity. However, do be very careful. You cannot say the limit are infinities because these are behavior. That's why the proper term is this, increasing without bound, and the other one, decreasing without bound. Okay? So ang ginawa muna nating technique ngayon, based on the graph, you can get these infinite limits. In a short while, gawin natin yung computational side. In fact, we can get these infinities by using some techniques. We'll do that after the next illustration. Okay? So again, let me be very clear. When we say infinite limits, we are observing asymptotic behavior. Okay? But then these are not limit that you actually approach to. These are just behavior. Increasing without bound, decreasing without bound. Okay? In the same manner, escape ko na lang. Discard. In the same manner, we can also get, nasan ba? Ay, na pala yun. Sorry, this one. Ay, hindi yan. Ito na. Ito na ba yun? Sorry. I forgot. Nalito na ako kung anong slides. Ito pa yung gagawin naman natin. Okay, in the same manner, pwede rin kasi natin magkaroon tayo ng limiting behavior when we look at the values of x increasing or decreasing without bound. Kaya na kasi ang ginawa natin, inobserbahan natin yung mga values natin from the left of -2 and from the right of -2. In the same manner, pwede naman natin gawin ngayon, tingnan natin what will happen to the function values as x increases without bound. So in symbol, you can write it as x. Ay, bakit nagkaganon? Ay, ito pala yun, sorry. Ay? Okay. Kumbaga, ito naman ang gagawin natin ngayon. Let me just change that. Gusto naman natin tingnan what will happen to the function values as x increases without bound and as x decreases without bound. What do we mean by this? When we say x increases without bound, we want to look at the behavior of the function as the values of x goes to the right without bound. Yun yung x without bound. What will be the behavior of the function values going here? Ito naman kabila, ito naman yung x decreasing without bound. Again, once again, these are just behavior. What will be the behavior of the function as x increases without bound and as x decreases without bound? I will again show you some table of values, but then again, there are shortcuts to this one. Let me show you. What will happen to the function values as x decreases without bound? Yung nasa left, ito namang nasa right as x increases without bound. If you're going to look at the values, -3, -5, 10, and then going to negative 10,000s. I know, sorry, negative 100,000s. Ito naman, 100,000s to the right. I'm not going to ask you to do this, but then if you're going to plug in values, these are the values that you are going to get. Look at that. From the left of, not from the left, as x decreases without bound, you look at the values of look at the function values. 3.0007 and so on. And you look at also the values from the right. I know, not from the right, sorry. As x increases without bound, on the right, ang sasabihin ko. 2.999933 and so on and so forth. And again, pwede nyo pang i-plug in 1 million, higher values and so on and so forth. But then for this one, we are going to see that there are some, in this case, asymptotic behavior again, but then this time there will be some horizontal asymptote. Kumbaga, as x increases without bound, you are going to observe that the function values actually approaches this line. This line is y equal to 3. Tandaan nyo isang technique na tinuturo sa atin sa algebra. Ang turo sa atin sa algebra, if you have a rational function, you can immediately get the horizontal asymptote. Kapag same yung degree ng numerator sa kanang denominator at hindi sila factorable or wala silang common factor. Di ba tandaan nyo, kukunin mo lamang yung component ng x sa numerator, that is 3. And then yung component ng yung constant coefficient ng x sa denominator, and that is 1. That will give you 3 over 1, which is 3. And that is precisely the horizontal asymptote that we are looking. Okay? Yeah, ratio between the, thank you for the term, Miss Leia. Okay, ratio between the leading coefficients. A better way of saying that. Yeah, thank you. O nga naman, okay? Leading coefficients, thank you. Actually, anyway, mag-bigaw sana ako about leading coefficients. Pero wag na, next time na lang. Okay, so kung baga may nakakausap, may kita yung horizontal behavior and that asymptotic behavior, and that the horizontal asymptotic behavior coincides with limits at infinity. If you're going to ask what is the behavior of the function as x increases without bound and as x decreases without bound, that will actually coincide with the behavior of the function if there is a horizontal asymptote. Okay? So in this case, as x increases without bound, the function values will approach that line, the graph will approach that line and also going to the right. Kumbaga, there is that link between infinite limits, limits at infinity, and horizontal asymptotes. Yung kanina naman, infinite limits and vertical asymptotes. But then more of that in a short while. We'll summarize that. Okay? So sige, diretso tayo. So this is how you write it. As x decreases without bound, and you observe that the function values approach a certain value, then we say that that is the limit. And you read it at this way, as the limit of the function as x decreases without bound is 3. We mean to say that as x goes to the negative infinities, the function values approaches 3. And also, x increases without bound. Dapat ito ay positive infinity. Yan. As x increases without bound, the values of this function also approach 3. And also, we mean to say that the limit of the function as x increases without bound is in fact 3. Okay? Medyo nakakabulol nga lang sabihin yung x decreases without bound, x increases without bound. Rather than saying x approaches negative infinity, x approaches positive infinity. But actually, ito yung tamang term talaga. Increasing without bound, decreasing without bound. But then for simplicity, I think it's also okay to read them as x approaches infinities. But then that will give an erroneous idea. We really don't approach infinity. All you can do is to simply observe behavior because again, infinity is not a fixed point or a fixed value. It simply goes on. Okay? Okay, so of course our problem now is how do I actually compute these limits? Yun naman talaga yung problem natin ngayon. How do we actually compute for these limits? So there are formal theorems for this one. I guess the guidebook that you are going to, the module that you are going to get in the Google Classroom, that will tell you the the module will give you the formal theorems. But then just to simplify our discussion for this afternoon, okay, this is a guide that you can actually use. Okay, how do you get limits at infinite limits? Actually, infinite limits will happen whenever you get a limit of the form k over 0, the numerator is of course not equal to 0. Di ba tandaan niyo yung 0 over 0, that is indeterminate? Ito naman, non-zero, okay, over 0. If you get a limit that is non-zero over 0, that is an indicator that we are going to get here an infinite limit. But then of course, the problem is which of the two infinities? So kumbaga, again dito, it's either positive or negative infinity. Automatic yan. Whenever you get a non-zero constant over 0, the limit will either be positive or negative infinity. But then the question is, which of those two? And here's a guide that you take. You simply have to compare the values. Let's say for the first one, if the numerator is positive, and then the denominator is 0, but then it is 0 going through positive values, kumbaga, numerator is also positive, and then the denominator is also positive going to 0, then the limit will be this positive infinity. Or it will increase without bound. Kasi there are only two ways to approach 0. Tama, di ba? Let's say over the x-axis, there are only two ways to approach 0. It's either from the positive values or from the negative values. In short, if we obtain here a 0 in the denominator for the limit, there are only two choices. You can only approach this 0 from the positive or from the negative. And that is what we are doing here. We are simply comparing now whether the numerator is positive or negative, and do we approach 0 from the positive or from the negative. So dito mahirap. Comparison lamang ito. Again, provided the numerator is already non-zero. Okay? So let us do this quickly. So if the numerator is positive and we approach 0 from the positive values, the limit will be this one, positive infinity. As compared with the second one, the numerator is negative. The numerator is 0, but then through positive. Negative over positive, that will give you negative. So that's why it's negative infinity. So it's like really just comparing symbols. You look at the right-hand side. Numerator positive, but then the denominator goes to 0 from the negative. So it's positive over negative. That's why the limit is negative infinity. As compared to this first one, numerator is negative. Denominator goes to negative. Negative over negative, it will give you positive. Again, what I'm just showing you here is a shorter version of the thing that you'll encounter in the module. In the module, naroon yung specific theorems for this one. But then this is a guide that you can actually use. Whenever you get a limit that is non-zero over 0, automatically it's infinity. The question is, positive ba or negative infinity? Okay?